Okay, here we go for example 4 of improper integrals. We have the integral from -1 to 0 of 1 over 1 minus x squared all to the 3/2. And so what I notice is I don't have an infinity or a negative infinity here, but I notice when I plug in -1 into this function, I get 1 minus -1 squared to the 3/2, which is 0. So I have to be careful here. That's the bound that I'm looking out for. So that's going to be the limit as b goes to -1, integral from b to 0, 1 over 1 minus x squared to the 3/2. This is a trig subintegral. I won't go through all of the reasonings because we've done trig sub. It's about the improper integrals. But x will be sine theta. Dx will be cosine squared. Just cosine theta. D theta. And I have the limit as b goes to -1 of the integral from b to 0. I'm going to make sure I know those are x bounds, not theta bounds. I'm going to do the full antiderivative first. That's 1 over 1 minus sine squared is cosine squared theta to the 3/2. I know I can simplify that, but times cosine theta d theta. That's the limit as b goes to -1, integral from b to 0, of cosine cubed theta is on the bottom, and cosine theta is on the top. So I'm left with 2 of them on the bottom. Okay, and 1 over cosine is just secant. So that's secant squared d theta, and we know just from our table that that's tangent. Limit b goes to -1, integral b to 0. These are x bounds, tangent theta d theta. I'm sorry, not integral of tangent, it's just tangent. Tan theta from b to 0. But these are x numbers, so I've got to change everything back to x's. Remember, x is sine theta. So draw my triangle. Here's theta. There's my right angle, and sine is opposite over hypotenuse. And I get 1 minus x squared under the square root, Pythagoras. So tangent theta is going to be opposite over adjacent. X over square root 1 minus x squared. Limit b goes to -1. I have x over square root 1 minus x squared from b till 0. When I plug in 0, I get 0 over 1, which is 0. When I plug in b, here's what I get. And now I've just got this limit to do. Okay, so what I'm going to do here is I notice that I have the limit as b goes to -1. When I plug this in, I end up getting a -1 over 1 minus 1 is 0. So I have 0 on the bottom. So I know this is going to be plus or minus infinity, but I have to figure out which it is. So that's negative limit as b goes to -1. What's some algebra thing that I can do with this? I cannot do L'Hopital's rule because I have -1 and 0. That's not 0 over 0. It's not infinity over infinity. So I got to figure out something to do with algebra. I think I'm going to factor a b squared out of all of this. I get b squared 1 over b squared minus 1. Do you see that? Negative limit b goes to -1. So root b squared, and b squared under square root of b squared is b, and then b and b cancel. So I'm left with 1 over square root 1 minus b squared minus 1 over b squared minus 1. So now what do I do? Well, remember, now I have 1 over 0. Remember, the bounds of integration were -1 to 0. So I have -1 to 0. And so I have it on my lower bound. So I'm doing -1 to 0, but the values of b that I'm letting approach 0 are going to 0 from the right, because this is the bounds of integration. I'm not going to be with these x values, because that's not where the integral is. So I have to do it from the right, which means 1 over b squared goes to positive. I'm sorry, I'm not explaining this well. This I'm explaining well, but how do I know which it is? Well, let me just sub in -1 plus in here. I want you to think of -1 plus something really, really, really small. So I have -1 over square root 1 over -1 plus squared minus 1. -1 over -1 plus all squared is like 1 plus. So that's -1 over square root of 0 plus a little bit. And then 0 plus is 0 plus. And so -1 over 0 from the right, think of it as, we know 1 over 0 goes to infinity from the right, and then I've got a negative sign attached. So this integral diverges. The integral from -1 to 0, the original one, diverges, and it goes to negative infinity. And that's the answer.